Okay, so welcome everyone to this new episode of Eaglefly, the experimental debugger. Today we will continue on programming and making this awesome debugger. And if you would like to follow along, you can do it without hesitation. If you have any questions, you can post them on Twitter or YouTube, and I'll be there to answer. With that in mind, I say that let's start with this recording. I've already opened the project and uh, there's some few changes that well the project well let me first clear these things. Now the last thing we did uh, was we've been discussing like about what we would be the next thing to do. um, the last thing we were doing, well, we were trying this multi-process uh, feature, or multi-process adding this multi-process debugging thing. And in fact, well, let me go to it. 132 should be somewhere here. Oh no, it's in the tracer. And also we make some ID table thing for us to handle multiple process IDs and thread IDs as well, and way to store it. That was the last thing we did. And now, I mean, we can go further that round, like trying to see more of the tracing stuff. And one thing that I was thinking about on the last stream also was that we should probably start thinking about how to, I mean, the symbol stuff and all this, we know that we have to have a disassembler. Let me, where's my command prompt? Here we go. And now, oh yeah, and one thing, I upgraded my Visual Studio thing, so now I have Visual Studio 2017, which is, well, it was something expected. It took me a while to transition to this. I was a little bit careful about when to change, but now I did, and it hasn't given me any problem. It hasn't given me any kind of problematic at all yet, but we'll see. So let me go and open SPC, well, and steps, sorry. And let me open the project. Oh no, I think, yeah, I didn't want to open a new project. I want to open the project that we have. So let me go to the, where is it? File, open. Oh yeah, it was here in the, alright. So if you see about it, I mean, if we run this project, and I'm gonna step on the first line so we can see it. Uh, Visual Studio has this disassembler that basically lets us see what the compiler spit out, like what does the object code looks like, and it's a second feature, I mean, it's not like a straightforward thing. I mean, the compiler doesn't make assembly language at all. It just passes through and translates every it can be some kind of direct translation, but what basically compiler does is to and we'll probably, I mean, it probably uses assembly language, probably not. But the point is that the thing that on the last thing that he does, on the first, even in the first part of making the object files and the object modules, he already parses the whole source tree and translate that into opcode, which is just the direct thing, or the direct thing that we were looking at on the PDB symbol information and the object file symbol information, where we see all the object code, especially for a test debug target that we have. So now the thing is like, well, we have all that stuff, and one important thing that I should mention is also like, well, we have to have a disassembler. One way we could do is to gather and grab some utility that's already made and use it for the debugger if that's what we're looking for. But I think something really important to mention here is that, especially for the project, is that we want to analyze and see by ourselves, like it would be nice for us to try to make the disassembler and see how it goes, of course it would be a nice try, because I mean, it would be a good thing to do for us to rehearse assembly language and to see a little bit more on the AI architecture part, how everything goes written up, which it would be like it would get us down to the bottom line, and that's what we are looking for, getting to the bottom line, seeing how things work on the low level, saying like, hey, this is what the processor is doing to the thing. And I mean, part of the process of debugging is first understanding what the processor is doing. I mean, that's the reason why we have like a lot of kinds of debuggers. Some debuggers are low level, like they directly connect with the JTAG circuit. In the circuitry, it can be like in circuit debugging, or it can be a high level feature debugger like Visual Studio that parses source level code, and you can see the direct translation. It's there are two different ways of debugging, and of course, I mean, it can be a debugger. I think that the debugger is pretty much defined by the architecture totally. I mean, the architecture itself defines, okay, what can you inspect? I mean, what are you looking at? What are the kind of utilities? What are the kind of scenarios? What's the thing that's happening? I mean, because of, if you think about it, the whole sense is to see and inspect what the processor, the architecture, it's doing. So yeah, I mean, so with that said, and this is nice. It's, I mean, I don't know how it's done basically, like this is assembler, but there's a direct translation. I mean, we can see. I mean, the whole point of this assembler is to gather this opcode by and get this, and find a way to make this translation from opcode bytes onto mnemonics and assembly language. That's the whole stuff. So it's pretty. I mean, it's a straightforward thing process in the sense that, in the whole sense, But of course, there's the caveats of how they are encoded, how instructions are encoded, stuff like that. Prefixes, immediate modes, immediate operands, addressing modes, stuff like that. I mean, all the sense, all that stuff. It's encoded in here. Like we know. I mean, we know that CC is the entry instruction. That's pretty straightforward. There are byte instructions. There are 2-byte instructions. There are n number of byte instructions. So yeah, I mean, there's some considerations there that we have to take a look at, but I think it's something doable. I mean, it's not super crazy to think about doing this day, and it's gonna be a good thing to do. Now, with that in mind, so let's start. Now the last thing, and another thing that I would like to mention is, like, for example, let me go to here and I will run dump binary. If you guys know this tool, it's a Microsoft tool that dumps executable files or any kind of binary, basically. I think object files as well, and cop files, object files, DLLs, exes, libraries, object libraries, and I think that's it. But what's going on here? No, I just want to know the options. Dump bang. Why can't I see the whole thing? There you go. Where is it? Dump binary has a tool that disassembles a binary file. Where is it? Here you go. Disassembler. So basically we have to say something like this. What about this? And I wanna, well, before this, I go to directory. There we go. I wanna do this. Eaglefly. I don't know if I wanna get the whole thing. Well, for example, I think this is cool. I already have a disassembly here. Well, disassembly, well, assembly language thing that I was just playing around with it. It's just a Fibonacci thing that we were doing up for testing. Where is it? is this one. Let me if he compiles. Here we go. Run. Okay, now the thing it's called, let me see, it's test build. We have this assembly exe, that object, and this debug target. Okay. Boom. It's gonna take a while. It's gonna since what I have on test debug target, it's a bunch of stuff. Well, it's not a bunch of stuff, but you know, the exe itself, it's huge, you know. But this is what we are looking for, you know. That's why I present this dumping. The thing that we are looking for is basically a dumping, you know, where we can like have this utility where we just call a disassembler or disassembler for a specific exe, and we get back the whole disassembly with the addresses, opcode bytes, instruction mnemonics, operands, and addressing stuff, you know, everything that's in there. So I mean, it's pretty straightforward. Now I don't know if I can stop this because I don't know if it's gonna continue to the end of time. Whoa. Is that all? Like, whoa. Okay, it's a lot of stuff, you see. Okay, awesome. So you see here, you know, this is the thing. We can see here the labeling thing that the disassembler finds, and this is normally the thing that happens when the disassembler finds, like, I mean, the whole point of disassembler is to find a structure in the whole opcode by pool of thing, you know. That's the main task of a disassembler, and it sometimes put these label things where it just categorizes things about what he thinks these sections should be about. If it's a procedure, if it's a system call, or if it's uninitialized data, initialized data, stack, or whatever. I mean, you know, everything. It tries to make sense of that, and sometimes, I mean, it can be. Sometimes it goes fancy and writes some naming in it, you know, like tell you, hey, this is the thing. It's not readable in current image or something. Sometimes he writes things. Probably, for example, this one is. Sometimes if he doesn't understand some specific part of the code, or if it's not really defined, it's just gonna put a label in it, you know, like this. Or this, I don't know, control floor point filter, I don't know, something like that. I mean, all the stuff that he uses for getting all that data. Close, fine, okay. Let me this. You know, one important thing to mention here is that when I want to focus the debugger around what we got from the disassembler, you know, because the disassembler is the one that's gonna make. I mean, even though and yeah, we want to get like these high level features probably of the C language itself, but I want that the base of the debugger be basically the target architecture, seeing what's going on the lower level, getting this, having this basic stuff being present from the first part, and constructing from that, you know. So yeah, I don't know what segment is this. You know, probably, I mean, this it has a zero runtime library thing, so probably we're linking on to the zero runtime library. Now let me run on the test asm.exe. And you see, I mean, there's no, I mean, if you think about it, this is just the thing, you know. Now this is another thing that we are, let me see here, because the last time we run the assembly, let me go to the build. We have test as here. Yeah, what I made here, I mean, if you know assembly or not, let me explain it to you. Basically, my assembly language, it's pretty straightforward. I mean, if you wanna run this is an assembly language file, you know, where I was like playing around with the assembler for 64 architecture, the MASM assembler, which is this one, you know, ML64. This is the assembler, and it runs pretty straightforward, the same way as the C compiler, C++ compiler from Visual Studio. You basically run some code. You know, assembler, you know, it's pretty straightforward. You know, it's just the opposite thing of what we want to do. It goes the assembly language like this, and it transfers it to opcode by, you know, and pretty much that's the straightforward thing, you know. And it's a way much simpler than having a compiler, which runs around semantics and stuff like that. But the assembler has a in many cases a direct translation from what you meant about instructions, you know, because there's no more than instruction in. You can have crazy stuff like macro things, but I mean, in the simplest things, it's just architectural instructions. Get it from the mnemonics way, and just a direct translation table. You know, you have a table and you translate each one for the opcode by. And that's it. So that's what the assembler does. And right now I have several ways. I have a bunch of little testing here. Let me see if I can run the message bus one. Message bus. So you can see. Well, I think I'm gonna do this. I'm gonna do this. I'm gonna do this. And I'm gonna assemble. I wanna assemble it for myself. So what I wanna specify is the same. Has no logo because I don't wanna see the crazy things that December's writes into the console. I have the W that it was, I don't remember what the W was, but it's a compiler option, and from the linker it's pretty much straightforward. We don't have here the C runtime library, and that's really good. That's why I mean, you see, this is the whole thing, this is the whole thing for this particular one, for the message box, I believe. Yeah, I think not. We're gonna recompile so we can see, but if we don't have the 0 and 10 library, the exe file is gonna be way super way much tinier. And yeah, so because we're gonna link it to the 0 and 10 library, and the only thing that we need for that is just to define that we want to have an application that runs from a console, and we link to the libraries that we need to call to the system, because basically what this process and what this application does is just calls to a message box, displays some text, and that's it, and calls to exit process. That's the whole thing here. So let me see. We use kernel leaf and user32 leaf, and we have to define the entry point because that's important. Since we don't have the 0 and 10 library, the entry point we have to define ourselves, and the entry point is pretty strict. I mean, we can define it here like this is the entry point. This one. Start proc, end proc, and that's it. Now let me see if I compile that. Of course, I have to define message box. Message box test, and I don't want to use that. So he doesn't see the start. It's because one result server symbol will have the start, I believe it was just this thing. Let me go to the spec, and I found out this thing. Where is it? This is an old file for Mason, which is basically tells us all the what the compiler, well, the assembler uses, and thus it's a spec for Mason assembler. Now, I mean, let me see if I have, because it says stored. Oh, probably it's because it has to be like that. Yeah. Now, alright, we have assembly, so we should have it here. Boom. Well, they're here. Test SM. It's super tiny. We don't have a lot of data information either, and it's gonna be that, you know. If you think about, well, we can take a look at it, so we can see what's in there. Yeah, well, the layout for Mason assembler, it's pretty straightforward. The way it works is that you define sections for for data, you know, as pretty similar what the P file does, you know, like sections. One is the data section, and another is the code section that we have here. And we define these external external procedures that we're gonna call from the system. That's gonna be exit process for exit process, of course, and message spots for just displaying that stuff. And if I show you here first, and yeah, so that's for, I mean, I can do this, I guess it's gonna be the same. Yeah. And on the data part, you define the whole set of variables that you want to define. You have it's totally different to see, just in the sense that dv, it's I believe it's a byte. What it does is basically it initializes a byte for that variable, you know, and that's it. So the caption is a byte variable that holds a string, you know, and this is the message. It's the hello world, and it's the same. It's a string that we define, and that's it. And the code part, you define a procedure in this way. You have it's like a blocky thing where you define the name for the label. It's like a label thing, and this is a special directive. Like I say, like, hey, this is the name of the procedure. Whatever it continues is the procedure, and we end it with this MP directive. And here in the middle of it, you can write any kind of assembly code. That's its support, of course, from the architecture. Right now we're using the x64 architecture, so we basically right here we just first we move the stack pointer down, so we allocate a little bit of it, so we can have some we can put their parameters and stuff. And right here we something really important here is to understand is the calling conventions, and right here we're using the C calling convention, which basically is a way to organize data to be passed up to a function. And this is the way that C does it. If we see the disassembly directly on Visual Studio, we will see something really similar, where the registers that get used and in the order that get used are RCX, RDX, R8, and R9, and these are the in that way, that's the order. So you can pass up to 4 parameters on registers to a function, so they can it's a kind of control thing, like a kind of organization, like, hey, I want let's organize in this way, I want to pass it in this order through these registers, and that's it. So that's why they're called conventions. But we have many conventions. Right now we're using the C-calling convention. It's pretty straightforward. And if you, of course, you want to have more parameters to be passed, you can pass them up on the stack. That's gonna it should be something more like what is it? Here's go. For example, here we have RCX, EDX, RAD, R9, and then we have right here I'm allocating, since I need to pass another one, a 5th parameter, I pass it up through the stack, and I just leave the same offset based upon the size of the registry, because later on I will move these registers up to the specific RSP pointers. So it's pretty much like if first you move down the stack pointer, so we can allocate those registers that we pass from the caller up to the stack allocation that we reserve for it. And yeah, that's it. So yeah, so we push the stack on the entrance for the call. And another important thing here to mention is that whenever you use the call implicitly is gonna subtract from the stack pointer size for allocation of the return for the return pointer. So that's something really important just to mention, because if we will see later, but I was just kind of mention that the call is gonna implicitly move down the stack, or it was 8 bytes. Yeah, well, since we are on 64, they are 8 bytes for a pointer, and it's gonna just be the pointer that is gonna use to go back to the caller function. So if we go back to the place where we are using it, we're using the calling convention to pass some parameters up to the function that we're gonna call, that's message box, which is here, and that's all. We pass the caption, the message that we want to display, and that's it. I think this is the helm, or the window handler, and this is the type of window, which is just a message of MBOK, and we call it. Then this is on the same way as we pass parameters on registers, the function can gives us back it can return data information on registers as well. And in this case, it's going to return us the exit code on the EAX register, which we pass on to the ECX just for I mean, it's not for nothing. We're not gonna do anything special with that, but it's just uh, for the procedure itself, you know. But you know, it would be just the same way if we want to use it. And then we call exit process. And well, actually, we use CCX because I guess we're gonna send it back to exit process, I guess. And that's it, you know. When we move TCX, exit process receives this parameter, and it exits the process straightforwardly, you know. And I think I have I don't have the Visual Studio for this, but I mean, let me run this so you can see. There you go. This is the message box, you know, pretty straightforward. 64-bit hello is the 64-bit hello that we have here. Hello world, the message, and that's it. So this is our first assembly program, and if you see here, I mean, it's pretty straightforward. How, and I mean, this is very important because if you just use this calling convention, the thing, it will be crashy, you know. For example, if we pass things on, for example, the message here, oh, here pass 0, if I compile, oh, well, pretty much better. This has to be well, for example, if I say, well, this is not, it's not gonna, well, it doesn't make sense, but I can say, well, I'm gonna show you with another examples because this is really, it's really simple, so you can see. But I mean, I was just wanna mention like this, the super important things about the calling conventions, because if you don't use the calling convention, the process is not gonna work. Just because, yeah, I mean, it's gonna be like the calling process is gonna be like, hey, this is not the order that I was expecting, and it's gonna do bananas, you know. So yeah, so this is the thing, you know. This is if we see the this assembly is pretty much straightforward. It looks pretty similar to it looks pretty much the same thing that we were writing here. We have a subtract RSP28H, which is this one. We should have a we have a move RCX0, load explicit address RDX, which is this address. This is the address in the data section where we have the caption, sorry, the message. Then from R8 we have the, for example, one thing that I can do, I don't know if it's gonna work, but even though if I say just caption and message, I think it's gonna work better. Yeah, I mean, it's just the other way around, but it doesn't matter. We have the move R90 R90 which is the same. Fact call, we have hit one thing is like, well, normal, I mean, the most straightforward thing that and that's why I put dump binary, because dump binary doesn't have access to the symbol information, and that's why it's not going to present us with a symbolic name or something, well, with a string pretty much, but it's going to show just the address, which is not so super special, but for starters it's going to work. This is the address for what the message box say, function call. Then we move EAX to ECX, and we call exit process, and these jumps here, we don't have it we don't have it here, but probably the disassembler thinks that they are also instructions that we set. Now this is 1402, or probably no, probably it is something that the assembler puts into, but it's just gonna go onto the end. If you see, I mean, this is a little bit lower on the opcode stream. It's something that's it's gonna jump like a little bit down, probably to the end of it, yeah. And we have a summary. We have a data, blah 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 blah, and that's it. So this is what we are aiming for. A way to display the opcode bats, mnemonics, and instructions themselves with operands and addressing modes. So let's try to start today. I don't know if we're gonna get too much on it, but I think it's good. And I mean, probably, I mean, I didn't show you a lot of assembly here. Probably we're gonna dive a little bit more on other streams, so I can show you more about assembly language and stuff like that. But I mean, I think this is really straightforward. I mean, well, this example right here is we will be exploring more examples. I can show you this Fibonacci. The difference with this between these two, for example, is that this is a standalone application. We compile the exe right here, but right here I use it just like for compiling specific mod functions or procedures, and I compile them. I generate the object file, and then I link that object file to a C program, and that's a neat thing to have whenever you want to write assembly language and you want to work with, and you want to have that on your C program, which is a little bit nice. And that's the only difference right here. Yeah, this was for a specific function, which I think I erased, but this is a Fibonacci, which is just, and this is a little bit crazy because I had to see the disassembly on Visual Studio. So I could see how the calling conventions were extracting these two functions, which was smprintf.s and call an output deduct string. So I could see, since those are from the C runtime library, well, specifically this is from the C runtime library, and I don't link with the C runtime library. I do link with the C runtime library, but the assembly doesn't know anything about this function. I just declare it as an external function right here, and then when the linking process starts, the C runtime library is going to be gathered from the C program, on the other part of the side, and it's going to link it to it. So it's it's this kind of the crazy thing that happens here. So yeah, I use that so I can call smprintf.s and to call output deduct string just the same way as we did with the message box thing. And for example, a nice thing that I have here is just I was just like making playing around with this and making some loop stuff. So how can I implement a loop? And it's just, I mean, the simplest thing to do is just to jump, and that's it. But to jump to another label code, right here I use labels, so I can jump across different code addresses, and that's it. I mean, there's not a lot to it. just the calling conventions, how to move data from registers to memory, from memory to registers, the size of it. I mean, right here you have to take a lot of consideration of if the data that you want to put into register fits to that register, you know. So you have just to get custom to always check the size of the things you're looking and moving up, which is pretty much the similar thing that you have with this strong type in C um, that you can define, but here is a little bit more tricky in that sense. Well, that's it. So yep. Alright, so let's go to, let me go to another panel here, and I think, let me go to, I think we have the parser for the object file. It was the P, yeah, here. These are P parser. For starters, I would like to, I mean, the thing that we're gonna do is pretty much read a P file or object file, doesn't matter. We're gonna start with the P file. Right here we have just the entry for the conf file thing, but I mean the P file is just other code branching here, so we can. I don't know if I want to do the same thing on both, but I think so, since they're really similar. We're gonna use this code that we have here. So we're gonna access to the P file. We're gonna grab the whole code back information instruction, and we're gonna start from there. You know, one place, the place that we're gonna take a look for the translation from the outcode thing, it's gonna be up. It's in the Intel spec. You know, where is it? I think it's this one. Yeah, this is the whole thing. You know, this is instruction format. This is gonna be the bread and butter for us to make this disassembler. So yeah. So for starters, I don't know. I was taking a look at this the last day. This is pretty much the structure for instruction. You know, the thing that was this opcode bytes right here has a format. You know, has a specific order for the processor, so he can understand it, and it has instruction prefixes, opcode, mod rm, which is basically the way that the addressing modes are are encoded with the scale index and base that we're gonna use for the addressing mode, the displacement as well, and the immediate if it has. You know, I think all of them except for the opcode are optional, and we have some special cases as the rex prefix where it's used on right here. You know, we can use the other kind of prefixes, but the rex prefix has to be just before the opcode byte, you know, or the opcode thing, which is this one. And for example, rex is a really important thing because rex has plays a lot with semantics of the opcode, so it's one of the first things that we have to construct around. But you know, we will see with that. But this is it. You know, this is the thing that we have to take a look on. Where is the? I don't know if I already closed. um, oh, for example, well, this is I don't know, guys, if you have let me put the charger. I don't know if you guys have seen this image before. This is an old I think it's from Windows NT. I don't remember, but I mean, this is an application. It's from Windows. It's called Code View, which is the reason why we have code view symbol information inside Windows. It's because of this debugger here. This is basically a way back debugger, which was it's a Windows debugger. You know, it was implemented by Windows by a guy. I don't remember the name, but it's a pretty straightforward thing. You know, it has, and if you think about it, it looks like pretty much similar like Visual Studio. You know, it is because Visual Studio comes from this debugger. And if you can see here, you know, I mean, we have pretty much the same things. We have the registry here. We have the memory space layout with the addressings and the ASCII translation. We have right here is the assembly thing. We have the data section, code section stuff, and the disassembly up here is the thing that it passes up to right here. And this image is really special because this is like the big picture about what we are looking for, at least from, I mean, this is like the basic, you know, this is a thing that we must have on the debugger as for starters. This doesn't have any C language. I don't know, I don't remember, but I think, well, since this is an assembly source file, probably, I mean, we just see the source file in assembly, but I think it also has C source level symbol information. Probably it was added after it, but you know, for starters, imagine that it was without C and stuff like that. We just have the disassembly, the, you know, the memory layout, the registry, and that's it. You know, there are some windows in there, super straightforward. Well, well, super. It's like this kind of more simplistic view of Visual Studio and stuff. But I mean, Visual Studio, I mean, it hasn't changed a lot for the time. It still has the disassembly. It has some watch windows, but that's it. You know, that there's no difference too much to this idea right here. So that's why I like this image, because it's kind of a good picture for what we are looking for in Eaglefly. And yeah, so yeah, that's why it was a nice thing to look at it. Now let me go. I think I closed the well, let me open it here. P file format. Let's see if we can get to the opcode itself for starters. So a file pointer is basically the location of an item within the file itself. So it's a file pointer. Okay, so the loader might not load the image at its preferred location. That's important. So I think for starters, for example, right here, and that's the reason why I wanted to get rid from the zero and 10 array, because well, one way we can do it, of course, is removing it in the C program, or another is just to write the assembly, and we'll get this. Like, but I don't know if the executable just have this code, or this assembler has a special configuration, so he understands that this is the only executable code that's going to be inside the file itself. We have to check that, but at least we know that there will be way much less code in this kind of app in assembly source executable, in this kind of execute, where we don't have this runtime library, and in that way it's going to be way much easier for us to understand the codebacks. So for example, we can start with parsing the exe for this image, try to find these codebacks, see the direct translation, and start to take a look at each one of it. I think that's for starters. So let's try to find out. And another good thing to have, let me go here, it would be to go right here, and I want to have this flag, these two, message box, I don't remember if it was FL or FO. Let me see. No. Yeah, it's FL. And which was W. Oh, it's the warnings. Okay. Yeah, it was the warning thing, which is good. Code view information. Which is the one we're looking for. So the Windows Visual Studio debugger, we can debug it into it if we find it useful. And this is the code listing, this is the warnings. Let me compile that. There we go. So if I open yeah, this is the code listing, which is nice. I mean, this is this similar to what we're gonna we should expect on the P file. We have the code bytes right here, which this is the assembler, which itself it's telling us, hey, this is what I understand about your instruction, so I'm gonna throw this code bytes, it's all about that. We have the data information, the code information, we have the procedures, which are, this is first one, start. We have, this is a procedure, sorry. It's text, which I think it's text means code, so yeah, that's good. It means a code symbol. And the length. other symbols right here are data symbols, like the external exit process, message box, test. Oh, this is the definition. Okay, caption and the message. These are not procedures, sorry. Or I don't know what L means, but this is a text. This is different for what, I mean, the real value, it's text or data, which is just the thing that we're looking for. So it's a nice thing to have, and something that the assembler spits out for us. And also, well, let me see if I can take a look at the disassembly for them. Can close this. Well, I mean, well, probably we don't care right now for that. So let me go to, oh my god. So we have a bunch of headers at the first part, which the image file uses, only uses them for MS-DOS compatibility. So yeah, we have to find out this one. Right now we don't care too much about these headers at all. We just care to find the offset to the P header so we can get to the reimport part here. We have an MS-DOS stuff, which is the signature, and then we have the call file header. Okay, so it's pretty much straightforward. Okay, and after the file headers, we have section headers. Okay, probably they got the reasons why they have this program in front of the file header. And probably it's more because of compatibility, you know, since MS-DOS was the first operating system. For Microsoft, they want to have that compatibility for the executable thing, you know. But anyway, you know, I mean, for MS-DOS, you have another different P file from. I mean, you have another file specification. So I don't know how they really differ, but it doesn't matter. Oh, okay, okay. So we can specify different stuff if we would like to. Okay. So let's just start by that. Let's try to get to the 0x3c file offset and see what we can get from there. So we have a p parser. I want to start over we have several things here with the two-way file. We have a p manager. We're gonna get down. So this is the cuff header. I don't know. I'm gonna say something like that. Now we don't know the size of the file offset itself, you know. We know it's over there. Uh, so I think we should take a look at that. Let's say we have, for now, something like this. Okay. Now I think let's compile this. Now I think I commented it so I can see a little bit better. So what I want to do, I have this is the one this is the file that I want to access to, this exe. I want to I'm not gonna compile that. I want to compile the p, which is this one, and I think that's it, isn't it? This is a p object file, compilation, check file signature. Okay. I was thinking like, well, signature, it has to have that thing, you know? So Now, one nice thing that I would like to have here. Uh, I don't know if I prefer this, and I can explicitly know what I'm looking for. I think, yeah. Since I mean, it's not just strings that we are parsing here. A P file is more. It has a bunch of data structures and different formats and types, so we cannot assume anything for it. Even though it's nice since it's got it, I prefer to do it explicitly here. So what I can say is something like, I think just for completeness, Let me see about it. I mean, we're pressing here a count pointer, but I'm gonna move this up back here so we can see a little bit better. And so there's a problem just about this one, or is it because this symbol? No. Let me put this back here. What about that? They have the same problem. And what about this? And what about this? Okay. And of course now we have to do this. Or we can say same thing. Well, we don't need it, I guess. course now, yeah, this is a problem. It's a little bit better. Now here we have to have same thing. And right here is the same. There you go. And the other part is the same. So let's see what happens over here. I would like to open Eaglefly PE parser. All right. How much longer you gonna take, Mr. Visual Studio? Come on. I just wanna. Jesus Christ. Why do I have both of them? Now the tricky part here is that I don't know where does the, let me see. The window for setting the values for the input, it should be somewhere here. Somewhere here. Here you go. Now the thing here is that we're gonna pass another file here, and it's gonna be this one. Alright, that's the thing. This is gonna be our place list, and yeah. Alright, so let's run this. We have file name, which is test build test assembly, yeah, test assembly 0.exe root. Good. I don't know what tests. No, it doesn't matter. File name, yeah, pb with retrieve, blah blah blah. Where we got it. Alright, we got it. Now we're gonna get the file offset. pp imager for. I wanna see this. Boom. This program cannot be run in DOS mode. This is a place. Now this is the place where we have, it looks like if it's dwarf, you know, but of course if we get the file offset from the file bar, from value from file, I mean if I say file offset, which is that, probably we're gonna get to the same place. Boom. Now piece signature, this is the one we're looking for. Probably is not here. Oh, this is the P. Here's the P. Is this place 504500? Pretty much we're looking for that, which is on CC. So what if we try to look it for a door? So I want to say, you know, probably I can say like this. So I want to say it's a shame. It's a shame. Probably we want something like this, you know, just for complete set of things, you know. I know what you mean. Now I don't know if, let me see if I can do this. If I say slide, if I add this thing and say, hey, in the IT now instead of byte I say is byte pointer, no, organic is byte pointer. What about that? He doesn't. He doesn't. It's a shame. Well, we go. We're going back. There we go. I want to see the file offset, which is the same, I guess. Now it's 208 bytes. It should be here, you know, the 504500. We can see here. Which is a little bit longer, isn't it? Because speed signature. Oh, now it. Okay, it works. It was crazy. It was crazy. Okay, now we have a P. You know, it's good. We know that it's working all right, so we can continue. We got the P. So now I would like to do this instead. Now I don't know how we want to do this. I mean, for handling and supporting both cuff parsing and P parsing, we just have to take, into consideration like how some of the tables they're gonna be there for different file formats, you know. So probably we want to do and I don't know if, let me see. Now I think yeah, well, I can do this for simplicity, I guess, for now, because for coder doesn't understand implicit ifs or one-line ifs, if I can say. So I can do that, and yeah. So here I'm gonna work with the other parts of the cuff header, you know. Now I think different purposes for different things, isn't it? I mean, the reason why we should parse cuff files instead of P files, it's a tricky question, isn't it? Right now we don't care too much about cuff files for the disassembler, since the whole I mean, the whole code information is gonna be explicitly on the PG file. Now, symbol information, of course, is gonna be extracted from PG files and it's not gonna be present in there. So we have to find it out somewhere else, like PDBs and stuff like that, like the way we did before. You know, that we haven't finished with that part, of course, but um, I mean, right now we don't care too much about symbol information. We care much about understanding the opcode layout, parsing the opcode layout, and getting the important pieces to recognize, to acknowledge um, what does the compiler itself make or understood about. I mean, what does the compiler opcode wrote about that, you know. So yeah, so I'm not gonna care too much about like how to implement like a both thing, because we don't know right now what do we want exactly from the code file view. So let's say we have I mean, all this code bunch, it was because we were like trying to see if we have some kind of idea of the layout of symbol information inside the PDB, you know, like this kind of chain thing, which we don't care too much about that. So what I like to do instead is something like this is interesting. The Windows loader limits the number of sections to 96. Now, the size of this exe, let me go to that's super um where's the test debug target exe? Of course it's gonna be way much bigger. So yeah, well, right now we just care about this 8,000 across 8,000 bytes, 9,000, 8,700 bytes. It's, it's such a little thing. So yeah. So we don't need this. Where is it? Since it's just contiguous, yeah. but here is gonna be I can take that. For now, we're just taking a look at x64 assembly, so I'm gonna keep this. We don't care about other architecture. The assembly is gonna be probably is gonna look at. I mean, we're gonna do it. I mean, we don't know how much of it, but we're gonna focus on the x64 and the i32, which is the architectures that we were looking that we've been looking at. So yeah. So we got that. We have to assert that. I can even assert it, you know. Well, I already do it here, but it's okay. P manager. What do we do here? Calf header, size of optional header. We don't need this right now. I just want to see what the cuff header can tell us about it. We have a number of sections. So we can have a setup here where we can see um, I'm gonna take this out, yeah. Well, I'm gonna put it right here. Car, we have a Kafka there, and the Kafka there is gonna tell us some stuff. Well, this is after it. I want to do it right here. Don't care about that. In fact, we don't care too much about anything of this, but Kafka there, characteristics, and image file, relax strip, and Kafka the characteristics, and I don't know if it's, yeah, I want to get this one. I want to start this for now. I don't want to do anything of this. I want to simplify this stuff, and later we can take a look at the conf extraction itself. Right now I'm just going to focus on the P file, so it's simpler after that we have these characteristics, you know. Something like this, something like this. And I always get it wrong. This is like this, and we can say that so if you think about it, I mean, there's a lot of information inside the P file itself, which helps us understand the opcode. You know, we have to take. I mean, we've had to grab all this information, make sense. Like, for example, if we are looking at, for example, we can take a look at this one and say, hey, we have a 32-bit word architecture, or we have 64-bit. You know, because I think the characteristics in the in the target machine, I don't see any about x86, which it should be x80. Well, it's this one, x86 64. the only thing that we have to look here is that uh, if we have a 32-bit machine, we're gonna do something different, you know. So we can say is x86 arc right now. Well, I mean, there are many aspects to think about when whether we are, I mean, when we are parsing x86 output bytes, and when we are parsing 64 uh, output bytes. You know, they change the way they are encoded are different. I know how they are encoded, of course, but we have to just think about that mm, when we are doing this stuff. You know, the aspects they're gonna change, of course, is gonna be a little bit different. So I mean, I wanna have that flag present for now, just to see what happens. So calf header, and this is inside the characteristics, and we have this, and I can say that I want to have this. Well, you know, sometimes 686 architecture. So P32 Plus allows for 64-bit address space while limiting the image size to 2 gigs. That means that when loading it, probably uh, okay. So we have 3 sections in the optional header. We have the standard fields, the Windows specific fields, and data directories. So the standard fields are common across different operating systems like Unix. I assume, I don't know. I don't know if that's what they meant about that. And the Windows, they have the systems that they handle, like the console, the application stuff, or OS2, or anything like that. Then the variable size, the data directories are okay. We have the import table and the export table. Okay, so the size of the standard fields is going to be 28 bytes, which is displayed here. So that means that if we multiply 28 by 8, 64, oh no. Okay, no, so I was not understanding this part because it says here that he has 8 fields, but I understand what size 8 fields are, but probably that doesn't matter because this is the whole thing, 1 2 3 4 5 6 7. Okay, these are the 8 fields. Yeah, these ones. Okay. was crazy. Okay. So it should be just about after the calf gather. I believe. So let me see. Okay. We have a different machine type. Which I don't know. Let me see. Five A4D. Mm. We don't have that architecture here, which is a little bit odd. So I would like to go here, see what happens. We have yeah, indeed, we have a PDF file. Oh, I put it wrong here. I put it all wrong. Should be the other way around, see? There you go. So we have an exception here where we're writing to a pointer. I'm gonna take a look at this, isn't it? No. So we have large address somewhere and the file executable image. We don't have relax. That's a little bit odd, isn't it? But what's the problem? Oh, okay, yeah, I see. I see the problem, yeah. So yeah, it doesn't has any relax strip, so we cannot count on that. But we should count on this, you know. There you go. And then we have that. We'll have an x86, okay. Oh, and of course we have a standard fields, but are they still gone? They're gone. It's a shame. So it's a 2OP, which means that's kind of crazy. I mean, how did we compile this? Well, since we know, I mean, we know this is assembler, you know. So it is compiled to be a P32 plus. Okay. You know, it's a little bit odd in the sense that but well, doesn't matter. So that means that the first bar, you know, is gonna be just that bar. We're not gonna have anything else extra. So for example, let me turn this back. We have the major link conversion and the minor link conversion of the linker itself. The size of the code, so 4K, and the size of initialized data, so 3K, and uninitialized data is 0, which makes sense. We don't have any kind of the address of entry point. It's a 4K something, okay, and the base of code, it's gonna be 4K as well. Alright, and we can say just for now that we can say here if standard fields magic to be, I want to define this here so we can let me pass this up to here. And also this as well. Now this is correct. We haven't done anything platform specific, which we should, but for now we're just focusing on Windows. Okay, so I'm gonna do this. I want to define, I want to put something here. So I want to say here, I don't know where the, well, that's okay. Probably we can put this on the platform specific thing. You know, I think I like it more there. find here. So I do this so I can see it more clearly, and we can access a little bit easier. So we have a way to access the data as a way that the loader does it, you know. All right. So I think I'm gonna stop here, but we will continue parsing the P file on the next stream. And yeah, so yeah, if you have any questions, you can post them on Twitter or YouTube, and I'll be there to answer. Yeah, I think today we was a nice stream. We made advanced some good work trying to understand the P file format, and yeah, you know, that's it. So thank you very much for coming up on this stream, and I will see you all on the next stream.